Hi everyone, welcome to the second week of the course. In this week, we are going to cover linear data structures that include lists, stacks, and queues. So far, in the previous week, we covered how we can analyze different programs given two code snippets or two different algorithms. This week, we'll start with a certain category of data structures, which is called linear data structures, which have some sort of linear ordering behind their logic. We'll cover lists, stacks, and queues this week, and in today's lecture, I'll primarily focus on the list data structure. So the agenda for today's lecture include we'll be covering what are data structures, what is abstract data types, and then we are going to discuss list as well as various implementations of the list ADT that include arrays, linked list, and different STL implementations. We are also going to discuss what kind of operations are possible on this list ADT, as well as the conceptual model or logically how they would work. Finally, we are going to compare the performance by using whatever we learned in the first week of the course, which is how to determine algorithmic complexity. And then we are going to see the C++ implementation of some of these ADTs. It's not possible to cover all the implementations of various methods or operations, but I'm going to cover a few so you can try out, and you have already done a lot of this in programming too. So let's get started. So, what are data structures? So, data structure is a way to store or organize data, and we can describe data structures by using two different constructs. The first one is more mathematical or logical. This construct is given by mathematicians, particularly, and we call this as abstract data types. So, an example of this is, let's say the mathematicians call a list of any particular collection or objects, and what kind of operations we can do on that is like we can store some numbers or store some objects, we can read some objects or numbers, and we can modify this data structure to either replace some elements or delete some elements. This conceptual model or mathematical model is more abstract in nature, and hence it's easier to understand for a non-computer scientist. So that's why we are going to focus on this particular description in first half of the course, which is the first 5 to 6 weeks. Another way to describe data structures is through implementation or through concrete steps, as we do in computer science. And we implement these data structures by using constructs such as, like let's say for list ADT, we could use arrays, linked list, vectors, array list. So while list has been defined more mathematically or it's more abstract, like we do not care about implementations in mathematical models. The second one is much more concrete, in which we have like arrays, linked list or vectors, array list or list, implementing this abstract model. So in case of C++, we'll see, or whenever we are defining our own list ADT, we could use like arrays and linked lists. Those are the most frequent ones. In C++, there's something called vector, which is equivalent to Java's array list, which is like a dynamically increasing array. And finally, there are lists which are in Python. So what I'm suggesting here is that the list ADT can be implemented in different ways in different languages. So let's talk about this abstract data types and more formally define this term. So I'm using this Wikipedia definition of abstract data types, which is it's a class of objects whose logical behavior is defined by a set of values and a set of operations. So I'm going to emphasize on the values and operations here, which is uh, all abstract data types have some sort of data or values, and they have some certain operations that are defined for them. So in this case, we do not care about the implementation of a particular data structure, but we basically care about how the data types are defined for certain data, as well as the operations that are defined for that particular ADT. An example of this is the clock, where a regular user won't care about how energy is converted into um, the motion of the clock, but what a user might be concerned about is like what is the time. So in this case for the clock, the data is something like what are the hours, minutes, and seconds, while the operations could be how do I read this clock, or how do I change the time on this clock, or how do I set an alarm on this clock, and so on. We are going to discuss in detail these different abstract data types, specifically in computer science, that include lists, stacks, queues. Then we'll follow it up with trees, graphs, and some other ones in the first 5 to 6 weeks of the course. In fact, heap as well, as far as I remember. And then we are going to focus the later half of the course more on the algorithms. So again, the ADTs comprise of more conceptual understanding, which is like how would the logical model of an ADT look like. But in the course we'll focus on three different things, which is not only how the ADTs work, but what are the operations that are possible on this ADT, as well as how we implement these operations and how we evaluate the performance. So the first few weeks will focus on all these concepts, which is logically understanding how ADT works, what are the operations and how we build them, as well as how we evaluate performance. And finally, we'll focus on problem solving, where we are not going to use like we can either use our own implementation or use like STL's implementation of these ADTs to solve different problems. You can consider that I might be using the Monday's lecture, which is the problem solving lecture, to focus more on this. So let's get started.